So this problem is asking, what are the concentrations of Na plus and SO4 2 minus ions in a solution containing 1.42 grams of dissolved Na2SO4 in 500 milliliters, assuming dissociation is complete. So assuming that the dissociation is complete, we can write the forward reaction that Na2SO4 is going to have a fully forward arrow of breaking up into its ions, which they told us already is the Na plus ion and the SO4 2 minus ion. And since the subscript on the Na is a 2, that means we'll have a 2 coefficient on the Na. Same thing with the SO4. We don't have parentheses around the SO4 polyatomic ion, so there is only one SO4 in the compound. So we'll have just a 1 coefficient in front of the SO4 2 minus, which means we can leave that blank. So in order to find concentrations, what we're looking for here is molarity. The molarity of each one of these ions. And molarity is a fraction of moles of the solute divided by liters of the solution. So they already told us that the solution is going to be 500 milliliters. So we can convert that into liters, 0.5 liters, and that will be what we plug in for the denominator of each one. But in order to find the moles of the solute, let's start with the grams of the total compound. So let's start with the 1.42 grams of the Na2SO4. And we'll need to convert to moles. And to do that, we need the molar mass. So grabbing the molar mass real quick. It is 142.04. So the unit of grams needs to go in the denominator for it to cancel. Moles will go in the numerator. And the molar mass always goes with the unit of grams. So 142.04 grams is in 1 mole. So multiplying by the numbers on top, dividing by the numbers on bottom, we get 1.42 divided by 142.04 gives us 0.009997. Not grams, excuse me. The grams canceled. That is moles of Na2SO4. So what we do with the moles is we know that from the balanced reaction that 1 mole of the Na2SO4 goes to 2 moles of the Na plus and 1 mole of SO4 2 minus. So let's start with the amount of the total, the 0.009997 moles of Na2SO4. And to convert to moles of Na plus, we would put the moles of Na2SO4 on the bottom and moles of Na plus on top. Since there's a coefficient of the Na2SO4 is just a 1, we'll put a 1 there, and a 2 coefficient for the moles of Na plus. So multiplying that out gives 0.019994 moles of Na plus. So you might be thinking, wait a minute, how can I get more moles of than what I started with of my ions? Well, one way to think about it is, like, say you have a dozen eggs, and each one of those, because a mole is kind of like a counting unit, like a dozen is a counting unit. So if you have 1 dozen eggs, then that means you have 12 eggs. But if each one of those eggs has a double yolk, then when you crack those eggs, you'll get 12 egg whites, but you would get 24 egg yolks. So that's how we're getting double the amount of Na plus than we got of the original, because there's 2 Na plus ions in each one of the original compound. Okay, so that's our moles there. And doing a similar idea, we could do a conversion for the SO4, but because they both have a coefficient of 1, it's actually going to be the same number. So without even doing the conversion, we can say it's going to be the same number as the moles of Na2SO4. So we would have 0.009997 moles of SO4 minus. Okay, so now we have our mole values, but the question is asking for what are the concentrations. So we need to think about what the molarities are. Let me give myself a little more room. And the molarity, so this first one is going to be the molarity of the Na plus. We can plug in the moles, is the 0.019994 moles of Na plus over, I'll go ahead and put moles of Na plus, over our liters, which is the 0.5 liters. And that gives us our molarity, which would be 0.03998 molar of Na plus. But we need to round our unit, we need to round our answer to 3 sig figs. So that would be rounding to this digit here. So this would round this up to a 10, so we need to go 400 molar Na plus. So that's our first ion. And the second ion, we just need to take the molarity of the SO4, or the moles of the SO4, so 0.009997 moles of SO4 minus, divided by the 0.5 liters. It's not a 4, that should be a liter. And plugging that in, 0.009997 divided by 0.5 is is back to this number again, 0.19994. And rounding that to 3 sig figs would be 0.0200 molar of the SO4 minus ion. So there we go. I hope this question was helpful for you. If it was, please like and share with anybody who you think might find these types of videos helpful. And please also, if you can, support me through my PayPal link down in the description, or my, what's that other one called, Patreon. Please and thank you if you'd like to support my channel. Thanks for watching.